Now that we've gone through both the endochondral and intramembranous ossifications, we have to figure out how do those long bones grow in length throughout childhood and into adolescence. So what we're looking at here now is what happens after the endochondral ossification. This is how things are growing throughout childhood and adolescence as the long bones, get longer. We're focusing on the epiphyseal plate because that cartilage that's left over, what was between the first and secondary ossification centers, that cartilage is how the bones continue to grow. So if we start here, we'll look at this reserve zone. Now, the reserve zone is a portion of this area. It's in the metaphysis. So it's between the epiphysis and the diaphysis. But this reserve zone is how it keeps this whole entire bone anchored to the epiphysis. Now, the epiphysis is going to be the end of the long bone, and that's how you keep that anchored. It's where you have the matrix being produced for the cartilage. So it's keeping things kind of attached. It's staying in remaining cartilage as long as the epiphyseal line is there. As long as the epiphyseal plate is there. So as long as the epiphyseal plate is there, that cartilage is remaining. Now, just below that is the proliferative zone. In the proliferative zone, looking at this area right here, this is an area of high mitosis. It's very mitotic. The chondrocytes are going through a high rate of mitosis to increase their cell numbers. They're becoming fully mature, and they're all set and ready to work. Those are the chondrocytes growing and growing and growing. So this is really where that layer can increase in thickness, preparing for more bone to be developed. You then have the zone of maturation and the zone of hypertrophy. In this zone, those chondrocytes come in from the top area, so we're talking about up here, and they're fully mature, they're fully functional. But as they move downwards, down towards where the bone is being formed, those cells start to undergo a little calcification. It's not the full entire matrix, but you're starting to calcify in this area. Remember, calcification of the matrix of cartilage is going to cause the actual chondrocytes to die off because those chondrocytes need diffusion for the nutrients to come in. Calcification, that mineralization, blocks the flow. So those chondrocytes die off, the cartilage matrix around it basically disintegrates, breaks apart, and that allows us to be in the zone of calcification. This zone of calcification, the matrix is calcified at this point, fully calcified. By fully calcifying the matrix, all these chondrocytes are dying off. If you notice, you're not seeing nuclei there anymore. There's no more of those purple dots for nuclei. So in the zone of calcification, that means the chondrocytes are dead, and we're just about ready to transition into the actual osseous tissue at this point. Because now, with the actual chondrocytes being dead, the matrix is calcified, blood vessels can start to work their way in. As blood vessels come in, and you start to grow into a little bit, then that allows more blood flow, more osteogenic cells, so osteoblast cells. Those osteoblast cells will start to ossify, and therefore we can create a calcified matrix that will create the actual bone tissue, the osseous tissue. So we're looking at now in the zone of calcification, what occurs at that point. Everything below that, down here, zone of ossification. You're fully making bone now. You're ready to go. This is the bone being created. This is the bone being developed at this point. So when you start looking at the long bones, how do they actually work? How do they actually grow? You can see that you have two different femurs here. You notice that the one says it's a growing long bone. You have the actual epiphyseal lines, or the epiphyseal plates there, the growth plates. The other one is the adult bone. The adult one, if you notice, has the gray lines. Those are the epiphyseal lines. At that point, there's no more cartilage. So what's happening here is you're looking at the actual bone And those, in this case, 3 locations that are the epiphyseal plate there, the epiphyseal growth is occurring in those cartilage areas. As the cartilage grows, it's pushing downward, pushing upward that way. The idea is it's pushing out, trying to push layer upon layer upon layer upon layer of cartilage. So as the cartilage grows, it's pushing it longer. And the old cartilage, that calcification zone, is where the cartilage is dying off and being turned into actual osseous tissue. So the whole process continues on throughout childhood, throughout adolescence, until full adult height is reached. Now, obviously, adult height is different for every person, but these will keep growing until the adult height is reached, or unfortunately, if damage occurs. Because if there's an unfortunate break of the epiphyseal plate and those cells can't continue to grow, that can cause problems while the bone itself is growing. So the growth in length of a long bone. But while these bones are growing in length, they have to grow in width also. The growth in width is referred to as appositional growth. Now I have down here osteoclasts resorb old bone that lines the medullary cavity. Basically what that's referring to as the inside lining, that endosteum, can be broken down. That is going to be broken down, the calcium is put into the blood. That can then be laid down outside with the periosteum. So it means you're pretty much taking the inside lining and creating and putting it outside, helping to increase the width. But the way that works is like this. This gray part here, this is the periosteum. So that's the outside of the bone. You notice there's a blood vessel there. What you're seeing is this periosteal ridge right here. That periosteal ridge is going to grow. It's going to end up coming together and forming this union right there. What that does by forming that union is you've created an entire circle, the start of an osteon. You have a blood vessel in the middle and then some space around it. Well, as this goes, each of these now will continue to grow inward. You'll form a ring of lamella, another ring of lamella. And you'll keep adding layers and layers until you've fully created the osteon. By doing that, you're actually creating the structure. When it's all said and done, you have a fully functional osteon as a unit of compact bone. But notice, another one is starting above that. So what's happening now is we have another periosteal ridge coming together, encasing a blood vessel, and that will then continue lamella upon lamella be forming rings. But each of these blood vessels remains attached. You'll notice back over here, we have that perforating vessel. It stays there right through the actual bone. The bone grows around it. So all these blood vessels remain attached. So if this was the outside blood vessel right here, the body needs to somehow attach that to another external vessel. It might create another vessel out here with a perforating canal going down, because you have to make sure that all these vessels remain attached so blood flow can keep going. So the idea of appositional growth, or the increase in width, is you're taking calcium, creating a thicker outside layer where the periosteum is, and if it's called for, you can remove the inside lining where the endosteum is. I say if it's called for because sometimes you're increasing the thickness to increase the strength. And if you're making it wider, it doesn't really help to then shave off the inside and make it thinner again. So it depends on what's going on and how the bone is responding. Appositional growth, increase in width, increase in length. 2 different ways the long bones are growing. But all this can also work with bone remodeling. Now, in the case of bone remodeling, if you notice I put up here, osteoblasts and osteoclasts are working together. That's because as a bone remodels, it's changing based on what the stimulus is. Maybe it was an old bone, or is injured, or you need more strength. The idea is those osteocyte cells for the mature ones that monitor stress and strain. If they have some indication that, hey, the bone's just not holding up, is not strong enough, they can go through bone remodeling to make it stronger. If the bone simply is older, can remodel to make it less weight if the individual is not using it. If it has a little bit of a fracture or break to it, can remodel to fix that aspect. The idea is bone remodeling will take calcium from where it's not needed and then add it to where it is needed. So the osteoclast will end up with bone resorption, removing the calcified matrix, and then the osteoblast will put it down, so lay down the new calcified matrix where it is needed. They'll work hand in hand to make sure the bone is at the optimal strength, optimal size, and everything's just right for the way the body is using it. And that also brings into play Wolff's Law. Now, Wolff's Law is looking at mechanical stress on the physical bone. What's happening here is the bone is going to remodel based on forces applied to it. Pretty much use it or lose it. That's the idea. If there is not as much strain or stress on a bone, let's say a person was an athlete playing sports competitively, then they simply just stop. They're not working out, they're not really exercising. We've done this for years, time to pull back. The bones don't need to have the same stress applied, which means they don't need to be as strong. The body will remodel it back, removing some of the density of the bone until the bone's strength and density matches the forces applied to it. But the flip side is true. If someone starts to work out or exercise or play a sport, and the body realizes, hey, these bones are taking a pretty good strain here, you can add more calcified matrix in, so creating more osseous tissue to accommodate for the increased strain or stress in the bones for the new exercise routine or the sport you're playing. So the body is constantly maintaining homeostasis, making sure the bone itself is matching the forces applied to it. So when you start having the bones increase in length, looking at the use of cartilage. When you have the bones increase in width, looking at the use of osteoclast and osteoblast to remove or lay down more calcium. Wolff's Law, stress is applied, remodel based on the stress that's applied. Your bones, constantly trying to maintain homeostasis, constantly trying to balance out the forces applied to make sure they're stable and strong enough for what you're doing.